So here, just a real quick refresher on how muscles work, but then something that's really quite interesting in insects. So on the left here is a very simple schematic that just sort of shows you the interaction between actin and myosin filaments. So this is, basic muscle physiology that you might be familiar with. And actin filaments tend to be very, very thin protein filaments, and myosin filaments tend to be the thicker one. And they have these heads, right? The molecules of the myosin, these heads that actually attach to the actin. And it's an integration of these two that produce a muscle contraction, right? So all of these filaments are housed within a muscle molecule, right? A muscle cell, sorry. And so I want to zoom in even further and just look at a individual sort of muscle cell and look very carefully at the insect system, because we have here what we call polyneuronal innervation, and I need to explain what it means, right? So in insects, the muscles, we have a phenomenon where a single muscle fiber is supplied by multiple motor neurons rather than just one. So in most systems, it is one motor neuron, one muscle fiber. In insects, you can have a situation where the single muscle fiber is actually supplied by multiple neurons. Now, what that means is each muscle fiber receives input from several different motor neurons, right? And so you have this sort of like a network of synaptic contact points, right, along the same muscle fiber. And they can be a mixture of inhibitory, fast, and slow, right? So inhibitory is crucial because your ability to block the noise allows you to generate a more specific and rewarding response. Then the excitatory means it's the favorable response, but you also have fast and you also have slow, right? Now, in integration, what this allows you to do is to have really fine control of muscle force, right? So the different neurons can activate the muscle to different levels of strength, different gradients of contraction, right? You can have a smooth force, you can have a variable force, but rather than nothing at all, right? So some of these neurons will then give you slow, sustained contractions. Others will give you very fast, strong bursts, burst type contractions. And then the inhibitory neurons basically reduce, they dampen so that you can fine tune the muscle activity. So when you integrate this all together, the simple idea here with these polyneural innervations is that you've got many, many control wires to one muscle fiber. The consequence of this is it's precise and is also very adjustable. So you need to think in the context of insects that in many cases need to operate very, very quickly, that this is a really, really ingenious strategy to make sure that when your muscles get used, they get used for the most efficient purposes.